Hello dear students, good afternoon everyone. Welcome to Oxford Patil's group of institutions. I am Chidanand, working as a lecturer in mathematics. So in today's class, I will be discussing about logarithms. So this is an important concept in mathematics and this will also be helpful in physics and chemistry as well. So before going for the actual definition, so let me consider an example. Through that example, we will give the actual definition of the logarithms. So here I will consider two positive real numbers. We know that 625 can be written as 5 to the power 4. 625 is a positive real number and it can be written as 5 to the power 4. That means 5 multiplied 4 times. Then we take another positive number 1000. This can be written as 10 to the power 3. So we all have studied about this form. This is nothing but the exponential form. So here 5 raised to 4 equal to 625 and 5 is the base whereas 4 is the index or the exponent or the power whereas 625 is the argument. So here this implies 5 to the power 4, this is equals to 625. 5 to the power 4 is equals to 625 and here 5 can be written as 5 is the base. 5 is the base and 625 is the argument. This is the argument and then 4 is the exponent or the power or the index. And here 4 is the index or exponent So this is the basic information. So now this exponential form can be expressed in the logarithmic form. So I'll write that now. Exponent form this is the exponent form and we'll write the corresponding logarithmic form. So logarithmic form. So now exponent form is nothing but 5 to the power 4. This is equals to 625. So this is the exponent form. Now the corresponding logarithmic form is written as log 625 to the base 5. This is equals to 4. Log 625 to the base 5 equal to 4. Log 625 to the base 5 equal to 4. So this is the exponential form and this is the logarithmic form. So this is the basic information. So note down this and then we'll give the actual definition of the logarithm. Well, now we shall give the actual definition of the logarithms. So the definition says if a is a positive real number other than 1 and a power x equal to m, then x is called the logarithm of m to the base a and it can be written as log m to the base a. So regarding this definition, we have few important points. Let me write the definition and then we'll discuss about the important points. If a is a positive real number, if a is a positive real number, if a is a positive real number other than 1 and a power x equal to m and a power x is equals to m and a power x equal to m, then x is called logarithm of m to the base a. Then x is called the logarithm of m to the base a to the base a written as to the base a, written as log m to the base a, written as log m to the base a. This is the notation. Here log indicates the short form of logarithm. So regarding this definition, we have a few important points now. So in log m to the base a, m should always be positive. So this is the first point. And then in log m to the base a, if m less than 0, then log m to the base a will be imaginary, whenever m less than 0. Now in case if m is equal to 0, if m becomes 0, then log m to the base a will be meaningless. It doesn't have any meaning. So this is the third point. And then the fourth point is the log m to the base a exists if and only if m greater than 0, a greater than 0, and a should not be equal to 1. So these are some of the four important points. So let us list out one by one. Important points. Important points. Important points. That point number 1, in log m to the base a, m should always be positive. M should always be positive. So this is the point number 1. M should always be positive. Then we'll write the second point now. If m less than 0, in this one, if m is less than 0, then log m to the base a will be imaginary. Then log m to the base a will be imaginary. This is the second point. Then the third point is, if m is equals to 0, then log m to the base a now becomes meaningless. Then the third point is, if m is equals to 0, then log m to the base a, will be meaningless. Will be meaningless. So this is the third important point. And then we'll write the last, that is the fourth point. So that is log m to the base a exists if the condition is m must be greater than 0. If m greater than 0, and then at the same time a greater than 0 and a should not be equal to 1, So this is regarding the definition of the logarithm and the four important points. So note down this, and then we'll move on to types of logarithms. Well, now we are going to discuss about types of logarithms. Mainly we have two types. In that first one, it is natural logarithms, and the second one it is common logarithms. So natural logarithms are also called Napier logarithms, whereas common logarithms are also called Briggs logarithms. So let us give the definition of natural logarithms. So the logarithms with the base e, small e, are called natural logarithms, and for the common logarithms, the logarithms with the base 10 are called common logarithms. So let us write the definition, and we'll give some examples for this. The logarithms with the base e the base e, the logarithms with the base e, we'll write the value of e now, which is 2.718, e which is equals to 2.718 are called natural logarithms. Are called natural logarithms. So natural logarithms are also called Napier logarithms. So let us give an example for this. Example, log x to the base e. Log x to the base e is an example for natural logarithm. And then another example can be log 50 to the base e. Log 50 to the base e. So these two examples are enough. Like this you can give so many examples. So this is regarding natural logarithms. The second type, it is common logarithms or Briggs logarithms. The second type, it is common logarithms. Common logarithms or the Briggs logarithms. So here the definition is, the logarithms with the base 10 are called common logarithms. The logarithms with the base 10, the logarithms with the base 10 are called, the base 10 are called common logarithms. Are called common logarithms. Are called common logarithms. So let us give few examples for this. So it is log x to the base 10, log x to the base 10, and other example can be log 25 to the base 10, log 25 to the base 10. So regarding the types of logarithms, we have two important notes. Let us give those important notes here. So here we have 2 points note, we will write them as note. The first one is log x to the base e can also be called as ln, that is a natural logarithm. Log x to the base e, log x to the base e can also be written as, ln, can also be written as ln, that is natural logarithm. This is the first point in the note. The second point is, in logarithmic expression, when the base is not mentioned, it is usually taken as 10. In logarithmic expression, when the base is not mentioned, when the base is not mentioned, it is taken as 10. For example, so whenever, if it is written like this, only log x is written and the base is not mentioned, in this case we take the base as 10, log x. And another example can be log 85. If they write only this, log 85, they are not mentioned any base here. The base can be taken as 10 in this case. So this is the second point. In logarithmic expression, when the base is not mentioned, it is taken as 10. So this is regarding the definition of logarithms and the types of logarithms. So note down this, and then we'll continue in the next class. Thank you.